Hello everyone, in the previous session of binary trees we have studied about what is a binary tree, terminologies involved in it, and we have solved some questions based on that binary trees. Now in this session what we are going to do is we are going to again solve some questions, and as I solve each and every question we are going to learn a new concept in it. Now let us start with our first question. The name of the question is diameter of a tree. So to understand what is the meaning of diameter, in 11th and 12th, in high school we have studied, right? We have studied a chapter called as two-dimensional geometry, or geometry in general, and in geometry we have a two-dimensional figure called as circle, and in circle the line which passes through the two opposite points of a circle, that thing is known as a diameter, and this diameter is the largest line that can pass through. This is also a line, but this will not be a diameter because it is not the longest. So in circle, when a line passes through two opposite points, that thing will become a diameter. Similarly, in trees, diameter is defined as the longest path between longest path, and this longest path is nothing but number of nodes between any two leaves, this is known as diameter of a tree. Now to understand it even more in a better way, let us take example that in the tree I have taken two trees as example, right? So in the tree one, let's say that I have three leaves, like leaf 1, leaf 2, leaf 3, let it be leaf 1, leaf 2, leaf 3. Now if you understand that the number of nodes present between these corresponding corresponding leaves, let's say that from leaf 1 to leaf 2, what are the total number of nodes? 1, 2, 3, that is 4, 2, 5. So the number of nodes are 3. Now if you observe from leaf 1 to leaf 3, how many number of nodes are present? 1, 2, 3, 4, 5. So the number of nodes are present will be 5. And if you observe from leaf 2 to leaf 3, how many number of nodes present? 1, 2, 3, 4, 5. 5 nodes are present. So either from leaf 1 to leaf 3, this particular path will become my diameter, or this second path, alternate path, will also become my diameter. Either one of this will become the diameter of that particular tree. So I hope you have understood that diameter is nothing but the longest path between any two corresponding nodes, right? Between any two corresponding leaves in particular. This is nothing but diameter of a tree. Now in this question we need, whatever the tree it might be given, we need to find the longest path, or you can say the diameter of that particular tree we need to find. This is the basic asking of the question. So I hope you have understood what is diameter and what is being asked in this question. Now let us talk about how we gonna do this. So before we talk about the approach, whatever the things I am going to do, before we do that, let us observe one thing. Let us try to analyze what is the diameter for these two different structures, for these two different trees. So I have taken two trees as example. This is my tree 1 and this is my tree 2. So if you observe one thing, that in tree 1, this path from leaf 1 to leaf 3 will become my one of the diameters. So I am considering this as my diameter, okay? From leaf 1 to leaf 3 will become my diameter, and it is passing through my root node, okay? Now let us observe the second tree. So if you observe second tree, we have again three leaves, leaf 1, leaf 2 and leaf 3. From leaf 1 to leaf 3, what is the length? That is 1, 2, 3, 4, 5. So the length is 5. And from leaf 1 to leaf 2, what is the length here? 1, 2, 3, 4, 5, 6. So the length is 6. And from leaf 2 to leaf 3, what is the length? 1, 2, 3, 4, 5, 6. Again 6. Now here you can see that I got again two different, you can say two different paths which gives the same answer. So the diameter length is 6 here. Now you need to understand that I got two parts here, two different paths. I am considering either one of this. I can consider either one of this because the length is same, right? At the end, I need to find the length, not the path. If it is being specifically asked that you have to only choose this path, then I will choose that path only. But in this question, we are being asked the length, the value, not the actual path. So I can choose either from L1 to L2, leaf 1 to leaf 2, or leaf 2 to leaf 3. Either one of this path, these two paths, these two different paths will give the same value. So I can choose any one of them. So here I am choosing from leaf 1 to leaf 2. So here you can see that this is my path I am getting. This is the path I am getting, and this is the root of the tree. So you can see that in my diagram 1, in my structural tree 1, I am getting my diameter through my root. In my second diagram, in my second tree, second binary tree, I am getting my diameter not through my through my root. It means that I am getting my diameter through one of the subtrees, sub part of my tree. Right now, can I extract one thing by observing just these two diagrams? Can I extract one thing? That is, diameter can be formed by two ways. Diameter of a particular tree can be formed by through ways. The first way is through its diameter. I can get diameter through its root. So if my path passes through my root, then I can get one of the diameter. Now the second the second consequence will be, if my diameter is not passing through my root, it means that through one of the subtrees. These are the two different possibilities I can get, and in this either I can get from left subtree. In this I am getting this from my left side of my tree, right? So I can get my diameter through subtree, and it can be from either left part or it can be from either right part, right? So I can get these from these three different, from through root, through my main root I can get diameter, or I can get through my left part, or I can get through my right part. Right now, what I will do is, now I am talking about the approach. So what I will do is, first of all, I will calculate diameter through root irrespective of the tree given. First of all, I will calculate the diameter value through root. After that, I will calculate the path through left subtree. After that, I will calculate the path value through my right subtree. So what I will do is, let me represent the path through root is dr. So here you can see that first of all I will calculate dr. After that, I will calculate the path length of left subtree. After that, I will calculate the path length of right subtree, and whichever maximum value is there, I will choose that maximum value. I will choose among these three different values which one is maximum. I will choose that value because my diameter is nothing but maximum value between two any corresponding leaves, right? So I will, whatever the maximum value returned by my left part, right part, and my diameter through root, whatever the value it returns me, I will choose that as my diameter. So I hope you have got the logic here. So I have extracted from these two different diagrams, I have extracted two things, that either my longest path can come from root node, or either it can come from subtree or subpart, and it can be like any of this. The subpart can be on the left side or subpart can be on the right side. Irrespective of that, I can get the longest path from these two different locations, from these two different you can say possibilities. Through my root node or through my subtrees, I can get the longest path. So if you observe one thing, in the first diagram I am getting the longest path through my root node. In the second diagram, I am getting my longest path through my subpart of my tree. So I hope you got the logic. I have extracted from these two different diagrams, I have extracted the logic. Now let us talk about how I am going to calculate the dr value. So I said that I will calculate dr value, left subtree path value, after right subtree path value, and after calculating these three, I will take the maximum value. So in order to take the maximum value, I need to calculate the values first, right? So if let us observe the first diagram. So for my path, longest path through root, I have to observe my first diagram. So if you observe first diagram, this is my root node, right? And what is the diameter? The diameter for this particular diagram is 5. And what is the left height of this tree? left height is 2, and what is the right height? Right height is nothing but 2. So can I say that my diameter through root dr is equals to left height plus right height plus my self node? This is the root node, right? I will add the root node as self node, so I will add 1. So this will give me diameter through root, and I will create a recursive function to calculate left diameter after the right subpart diameter. So let us talk about the approach in detail, because this diagram looks kind of messy. So what I said is, I have extracted three things, to be specific, 3 things, that I will calculate diameter through my root. Irrespective of the given tree, I will calculate the diameter through root. So this is my root, right? So the first step will be, I will calculate diameter through root. So I have extracted from the previous diagram, I have extracted one thing, that is diameter through root is equals to left height of the tree plus right height of the tree plus 1. This thing will give me the diameter through root value. Now here you can see that diameter through root is this is the left part, right? So what is the left part height? Left height is equals to 2, and this is the right height. What is the right height? Right height is also 2, and this is the node. Let's say that I will calculate, I will include my self node as 1. So my diameter through node will become 2 plus 2 plus 1. So this will become 5, and I have manually also calculated that the answer is 5, right? So my diameter through root will become 5. After calculating diameter through root, again I will calculate the diameter through left part of my subtree. So I will call a diameter function. So I will create a function, recursive function for a diameter. Let's say that I am creating a diameter function here. I am creating a diameter function, and in this I will pass my root node. Now in this function I will recursively call my diameter function for the left part. So for this left part I will calculate left diameter. So for this, what is the left diameter? Excluding my root node, the left diameter will be the maximum. Let's say this is my leaf 1, leaf 2, right? So the left diameter will be 3. So I will calculate whatever the value it is given. So for my given tree, I will calculate the left diameter. After calculating the left diameter, I will calculate my right diameter, and I will show you that how I am going to calculate. I will show you a dry run on this question. So after that I will calculate the right diameter. First is I will calculate diameter through root. After that I will calculate diameter through my left part, diameter left part, after diameter right part. And in these 3 values, what is the maximum value that will become my real diameter of my tree? So among these 3 values, which one is maximum, which one is maximum I am getting, I will make that as my tree diameter. I hope you got the logic here, right? Now first of all, let me write the pseudocode, and after writing the pseudocode I will do a dry run for this particular tree. So let me remove all this thing. So I will create a function, diameter, and here in this I will pass my root node as my parameter. Now what I will do is, first of all I need to calculate diameter through root, right? So the first step is diameter through root. So I have extracted a formula that diameter through root is equals to left height plus right height plus 1, right? So before like applying this formula, I need to have the values of left and right? So what I will do is that I will calculate left height is equals to, and in the previous lecture I have calculated the height of the tree. So what I will do that I will call the same function now. So I will call height, and I will pass the left side of my tree. So I will pass root dot left. And similarly for right height is equals to height. I will call the same function height, and I will pass the right side of my tree. So root dot right, I will pass that now, right? And after calculating left height and right height, I can able to calculate my diameter through root. Now I have calculated diameter through root. Now I need to calculate my diameter for my left part. So I need to calculate left side diameter, right? Left subtree diameter. So what I will do is that I will create a variable left subtree diameter, and for this I will call my recursive function. So I will call the same recursive function, but instead of my root I will pass this subpart. So root dot left. After that I will calculate the right part, right subtree diameter. So right subtree diameter is equals to diameter of, now I will pass the right side of my tree. So root dot right, I will pass the right side of my given tree. Now what will be the base case? The base case will be if my root becomes null. Through my recursive function I am reaching a null case, then what I will do is, if my root becomes null, then I will return 0. Right, this is the overall code, this is the overall algorithm of my given diameter, calculating diameter of my tree. Now let us do a dry run. So let me remove this thing here. What I will do is, let us say that I am taking this node, the 4th node, as my, like in my function calling I am at 4th node. So what this 4th node will do is that first of all it will calculate the left subtree diameter. It will call this function left subtree diameter, and this function will return 0 because here I am having a null value. So left subtree diameter function call will return 0. After that I will calculate right subtree diameter, and here also I am having null, so this function also returns 0. Now my left subtree is 0, my left subtree for this thing is 0, and right subtree diameter is 0. After that I will calculate my diameter through root. So diameter through root is equals to left height plus right height plus 1, right? So for this, the left part, there is no left part, and for this particular 4th node there is no right part. So my diameter through root will become, this is 0, and the value of 1. So my diameter through root will become 1. So this diameter through root will become 1 now. So what I will do here, let me remove this. So I will choose my actual diameter is equals to maximum value of diameter through root after LSD, after RSD, right subpart diameter, left subpart diameter. So here LSD is 0, RSD is 0, and DR, diameter through root, is 1. So what this 4th node will return to its previous function call is maximum value of among these 3 things. Among these 3, which one is maximum? That value will get returned by this 4th node. So this 4th node will return 1. Similarly, this 5th node also returns the same value because the structure of 4 and the structure of 5 is literally the same. So this 5 node also returns the same thing, right? Now for this 2 node, left subtree diameter is 1, and right subtree diameter is also 1. After this diameter through root is left height. What is the for root 2? What is the left height? Is 1. So 1, and what is the right height for root 2? 1, and plus itself 1. So this thing, diameter through root will become 3, right? Now the LSD is 1, RSD is 1, and diameter through root is 3. So which one is maximum? I will return that. So I will return 3 to my root node. Now after returning this, my function will get called similarly for this right part also. I will call for this right part. After left part, I will call for the right part. So this will call this, and this will call null node, and again I will reach my base case. So this will return 0, and this will return 1. So for this, the LSD for this 3 node, the RSD is 1, and LSD, there is no left node for this root 3, so LSD will become 0, and the diameter through root 3 is equals to right height. Right height is 1, so right height plus left height, that is 0 plus 1. So this will return true, 2. Now the left part for this root 1, the left subtree diameter is 3, and the right subtree diameter is 2, and the dr for root 1 is equals to the left height. So what is the left height? Left height is 2, and the right height is also 2, and the root itself 1. So dr 1 will become 5. So for this particular node, LSD is 3, RSD is 3, and dr 1 is 5. So which one is maximum? that is 5. So I will choose that as my diameter. So I will print finally this diameter value, which is nothing but 5. So I hope you have understood how function calling happens and what are the things I did. And you need to keep faith on your diameter function. You need to keep faith that somehow my diameter function will calculate the left side diameter after the right side diameter, and this value, whatever the value I am getting through my diameter through root, after the left part diameter, right part diameter, I will take the maximum value among these three. That thing will become my diameter. Now let us code this thing. By coding this, it will become even more clear for you guys. So in the program, I already have a height function. So this height function will return the height of a given tree. Now I have created this tree in my main program. Now first of all, what I will do is that first of all I will create a function public static. I will create a int type function because I am going to return diameter length. So int diameter. In this I will pass my root node. So node root. Now what is the base case here? The base case is that if my root node is null, that is root is equals to null, then what I will do is I will return 0. Now after that I will call the right height and the left height function, and I will calculate the dr value, diameter through root. So I will create int dr is equals to height. I will call the height function for root dot left. After that I will add here height function for root dot left, root dot right. After that I will add +1 here. Instead of writing this in a same line, it might become a little bit confusing to you. So for that I am creating different variables. So int lh is equals to height function for root dot left. So this function will calculate the left height. After that int right height is equals to height of root dot right. So this function will calculate the right height. Now here, instead of giving direct function, because it might become a little bit confusing to you guys, such that here I will write RH and here I will write LH. So left height plus right height plus 1, this will become my diameter through root. Irrespective of the given tree, I will calculate the diameter through root. After that I need to calculate the left part diameter and the right part diameter. So for that I will calculate LSD, left part diameter, is equals to, I will call my recursive function now, diameter, and I will pass the left part of my tree. So root dot left. Now after that I will calculate int RST, left part right part diameter is equals to diameter, and I will pass the right side of my tree. So root dot right. Now what I will do is I will return the maximum value. So math dot max of my dr, diameter through root. After that again I will write math dot max of LST comma RST, because I am writing this math dot max 2 times, one in outside of my function, after that one in inside parameter, because my math dot max function will take only 2 parameters. So in this internal parameter, which one is maximum, I am passing this as my external math dot max function parameter, right? After that I am returning. Now let me save, and in the function I am calling my diameter function. So diameter, and here you can see that my diameter value will become 4 plus 2 plus 1, or you can say from 4 node to 2 1. So my value will become 5. So if I run this code, then my output should give me 1 2 3 4 5. Okay, now let me save. So my diameter value should be 5 if I run this code. Now let me save and run. So you can see that I got the diameter value as 5. So this is how I will calculate the diameter of a particular tree. So what I did is that first of all I have created a diameter function. In this my base case is root node. If my root node is null, then I will return 0. Now after that I am calculating the left height. I have already created the height function. So I am using the same height function which we did in my previous session. Now After calculating left height, right height, I am calculating the diameter through my root node. After calculating diameter through my root node, I am calculating the left part diameter and the right part diameter through my recursive function calling. Through my recursive function calling, I am calculating left diameter, right diameter. Now these things will return me some value, right? So among these three things, which one is maximum, I am returning that, I am printing that as my output. I hope you got the overall approach and the overall understanding of the question. Now let us talk about another question. Now in this question, I need to tell whether the given subtree is a part of my main tree or not. So in this, I will be given the roots of two binary trees, which the main root is known as the main tree root is known as root, and the subtree which I have given, I am calling its root as subroot, and I need to return true if the subtree of that root lies in the main tree with the same structure and the number of nodes value are also same. If these two things are same, then I will return true, else I will return false. Now let us understand what is being asked, not just by words. Let us understand the true essence of this question. So this is my main tree, right? I am calling this as my main tree, and this is my subtree. I need to find that whether this subtree lies in my main tree or not. And how I can tell that whether a particular subtree lies in my main tree or not, based on two things. First one is structure. If my subtree structure is as same as the main tree structure, subtree structure, this is my main tree, right? So this is my subtree of my main tree. So if the subtree matches this tree, then I will return true, and along with the structure, the values should be true, like the values should be the same. It means that this is my subroot, right? The subroot value should be equals to this, and this value should be equals to this, and this value should be equals to this. If these two condition matches, that is the nodes value should be same and the structure of these two trees should be same. If these two conditions satisfy, then I will return true as my output, else I will return false. I hope you have understood the asking of the question. Now let us talk about in detail, in depth, what is like actual asking on different variations. I will take different variations and I will try to analyze the output for that. So here it is telling me that the structure should be same and the node values should be same, and you need to understand one thing, that understanding structure will solve around 50% of our problem. If we understand what is the meaning of structure, then our 50% of question is solved. Okay, now here let us say that this is my subroot, right? And this is my main tree, and this is the root of my main tree. So what I will do, that in my main tree I will try to find out the subroot, whether the subroot is present or not. And as I find my subroot, so here I find my subroot, right? This is the subtree and its subroot is found here. Now after, I will see its left part and I will see this tree left part. After that I will see this tree right part, and after that I will see this right part. If these two things got matched after finding my subroot, then and only I will return true. I hope you got the thing here. Now let's say that, let me remove the link here. Now let's say that here I am having some node 6 I am having here. Now first of all, what I will do is that from my root I will find my subroot. So this is my subroot, right? So I will try to find this subroot in my main tree. So here first of all I will iterate, or I will do some recursion work, and I will try to find my subroot in my main tree. So I have found out my subroot. So after finding my subroot, I will see its left part and I will see this subtree left part. Here you can see that the fourth node is correct. Fourth node I am having. After that, here on the right side I am having this fifth node. But the difference is that on the left part there is a extra node in my main tree, and in the subtree I don't have any extra node. So this thing will return me false because the structure is different. There is a structural difference in these two trees. I hope you got the thing. Now I can take another variation also, that let's say that here I am having some node 6 here, right? On the right side of my tree I'm having some node 6. So what I will do is that first of all I will try my subroot. I will try to find out my subroot in my main tree. So I have found out my subroot here. Now I will see its left part. So in the left part I am having 4, and for 4 there is 2 null nodes. On the left side there is null, on the right side there is null. After that, on the right side I am having 1 node, and for 5 also there is on the right side null, left side null. Now I will compare this to my subtree. So this is my subroot is matched. Okay, now after that see its left part. So if you see the left part, the value is same. Here the value is 4, the value is 4. Now if you observe for 4th node, the left part is null and the right part is 6. Here I am not having any 6. And if you observe the right part I am having 5, here also I am having 5. Okay, good. And its child are null. Here null, here null. Okay, everything is satisfied, but the values are same. The values are same, but the only difference is I am getting a structural difference here. Here you can see that I am getting 6 and there is no 6 here. So this variation is also return me false, will also return me false. So I hope you have understood the structural difference. Now from this tree alone, let me erase the ink again. So let us talk. I hope you have understood the question, what is being asked. I need to take care of 2 things. If my subtree satisfies these 2 things in the main tree, then I will return true, else I will return false. And what are these 2 things? First thing is the structure should be same, and the second thing is the actual node values should also be same. If these 2 things satisfied, then I will return true, or else I will return false. I hope you got the logic here. Now what I'm gonna do is I'm going to talk about the approach of this question. So first of all, what I will do is I will try to find my subroot in my main tree. And here what I will do is that first of all I will iterate. I can put any iterative method. I can also use here level wise traversal, or I can use any recursive like pre-order or post-order traversal, whatever. I will put a traversal technique on my main tree and I will try to find out the subroot in my main tree. And after finding the subroot, I will check whether this particular tree, whether this subtree is identical in this part or not. If it is identical, then I will return true. If it is not identical, then I will return false. Okay, got my point? Now how I can tell that whether this subtree is identical to this part? So to tell whether the tree is identical, I am checking the conditions are, instead of checking that each and every condition that this should be same, this should be same, instead of checking identical, I am checking what are the conditions for not being identical. If I can point even one thing, then I can tell directly, I can return directly false. Because if it not satisfied, if it doesn't satisfy any of given at least one condition, then it is not identical, right? I hope you got the logic. So what I will do that instead of finding the conditions for identicalness, I will find the conditions for inidentical, so not identical. So I will find the condition for not identical. So if the tree is not identical, I will return false. So the conditions are, first one is the node.data, that particular main tree node.data should not be equals to the subroot.data. If these 2 conditions, if this condition is true, it means that here I am having some value 3 instead of 2 and my subroot is 2. If both values are not same, then I will return false. For example, I can give you a teeny example also. That let me remove this. Okay, let me remove this. Okay, and again choose the pen. Okay, now here instead of 4, I am having, let's say that I am having 10. So subroot is matched. Here the subroot and this node are matched. Now what I will do is I will check for this particular node what is the value 10, and for this particular subroot What is the value? 4. Both are different. If both are different, then immediately return false. This is the first condition. And the second condition is, if my node is null, if my node, main tree node itself is null, or my subroot is null, then I will return false. It means that my subtree is itself null, then I will return false, because there is no anything to search, there is nothing to search in my subtree and main tree, right? This is the second condition. If my subtree is itself null, then I will return false. And the third condition is left subtree, left subpart should match with subtree left part, right? This particular part should match with this part. And the fourth condition is right subpart in the main tree should match with subtree right part. So these are the 4 conditions. If any of these 4 conditions get violated, gets true, then I will immediately return false. So these are the 4 conditions of not being identical. If any of this gets true, gets satisfied, then I will return false. I hope you got the logic. Now let us code this thing. By coding this, you will understand it even in a better way. Now in the main program, what I have created is, I have created this subtree. After it, this is my main tree. Okay, now after this, what I will do is that I will create a function, public static, let me give boolean, because I am returning true or false, right? So is subtree. In this I will pass my main node root data, after it node subroot, right? After it, my condition is, if node is null, if the root is null, if the root itself is null, it means that there is no tree. Then what I will do is that I will return false. Now after that, I will check if my subroot dot data is equals to node root dot data. If these two are same, here I need to give double is equals to. Okay, now if these two are same, then what I will do is I will immediately call for another function which will check whether the given 2 trees are identical or not. So for that I will call if is identical. In this I will pass my root and subroot, and if this is true, then what I will do is I will return true. Else what I will do is I will return is subtree for my root dot left part, and after it, or root is subtree for root dot right part. Okay, now let me create a is identical function which will calculate the whether the given 2 trees are identical, whether the subtree is a part of my main tree or not. So I am creating public static boolean is identical. In this I will pass my node root, after it root node, after it I will pass node subroot. So what are the 4 conditions? That if my node is null, if my node is equals to null, if my root here I will pass, instead of root I will pass a node. So if my node is null, or and my subroot is also null, it means that I have reached the end thing of both structures, right? Both trees. For example, here you can see that here, let me show you. So let's say that I have this value here 4. Now through my recursive function calling, I have reached null here, and I have reached here also null. So if these both are null, it means that the top level is somehow true, the recursion function is working. Then I will return true from this side. If I have reached the subroot and the node, here this node and the subroot, I have reached these both things as null, then I will return true. I will return here true, return true. After that, I will create a function, I will create another statement, if else statement, if else in the condition what I will do is that if my node is null, if node is equals to null, or my subroot is null, or node.data is not equals to my subroot.data. If both are not matched, then what I will do is I will immediately return false, because the data is not being matched here. Now after that I will create another condition that if is identical is not true for my node.left part and my subnode.left part. If this condition returns me false, then I will return false. After that, for my right part, if this also is identical, returns me right, and subroot dot right. Okay, here I need to give subroot. Okay, instead of okay, subroot. Now it is sorted. Subroot dot right. So this is the thing, right? After it, if all these conditions are true, if this here I will return false. After that I will return true here finally. Now in let me summarize what I did is, first of all I have created a function called as is subtree. Here I am checking that if my root is null, this is a base case. If my root itself is null, then there is no comparison, right? So I will return false. After that I am calling after that I am checking my subroot.data and my node value. If these two are same, if these two becomes same, then I will call is identical function. And if is identical function returns me true, then I will return true as my output, right, as my output. Now in is identical function what I am doing is that if my node is null and at the same time my subroot is also null, then I will return true, because this is the last end of this both two trees, and as I reach last end and I haven't returned anything, then it means it's an indirect implication that both structures are same. That is why I am returning true. And in the else if statement I am checking that if the data is not same, then I will return false immediately. After that I am calling my recursive function calling for my right part, for my left part of my given tree, main tree, and my for left part of my subtree. I am calling this by passing the left parameters. Here I need to pass root, not road. Okay, root. Okay, here I am passing my subroot. Okay, subroot, left part subroot, right part subroot. After that, similarly I am calling the same function for my right part. If I am not returning anything, then finally I will return true. So if this function is true, then I will return true. Now in the last statement what I am doing is that if either my subtree is lying on the right side or on the left side in my main tree, if either of this condition gets true, then I have to return true. So if this function, any of this function returns true, then I will return finally true as my output. Now in the main program I am calling my function. Let me call my function is subtree. Now here I will pass my root, after it my subroot. Now after calling this, here you can see that this is my subroot diagram and this is my main tree diagram. So here let me remove this. Okay, now let me save, and if I run this, then I should get my output as true. So you can see that I got my output as true. So this is how we will calculate that whether a given subtree is a part of my main tree or not. So this is the code. This is the code for calculating whether the given tree is identical or not. This is the code. I hope you have understood the logic, the working code of this overall thing. Now let us talk about other interesting question. Now the name of the question is top view of a tree. So in this we will be given a tree and we need to print its top view. So what is the meaning of top view? We need to understand the meaning of top view here. So the meaning of top view is that, let us say that this is my tree, right? So on top of, you are seeing the horizontal, horizontal view of this particular trees. Now if I want to see the top, from the top side, if I see the tree, then what are the values I will see? I need to print those values. This is the basic asking of my question. Now to understand this question, let us say that I have fixed a lens on top of this tree. So this is my lens and I have fixed the lens, and if I see from the top side, then whatever the values I am seeing, I need to print those values. So you can see that I can see, let's say this is my big lens here, right? So here I can see the fourth node. After that I can see the second node. After that I can see the first node and the third node and the sixth node. This will be my output, and I can't see 5 and 4 because it comes directly under 5. So if I draw the diagram, I am showing you diagram for your understanding, but if you see in real essence, real binary tree representation, my tree will look like this. Like let's say this is my first node, right? Second node, and this fifth node will come directly under this first node, and this fourth node will come directly under this first node, and because of this first node I can't able to see this 5 and 4 nodes. From the top side I can't see 5 and 4 because of this first node. I hope I have understood. So from the, if I see from the top side, then I will see my tree something like this. These are the only nodes I will see from the top side of my tree. If I see the tree from the top side, then I will see first 4, after 2, after 1, after 3, after 6. So this is the working, this is the asking of my question. From the top side, if I see my tree, then what are the nodes I am saying? I need to print those nodes. Okay, now if I run this code, if I dry run this for this particular second tree, so let us say that this is my lens. So for this I can see node 2, after that I can see node 1, but I can't see node 4 because this directly comes under 1 and 1 covers node 4. Because of 1 I can't see node 4. Okay, now after that I can see node 3, and because of 3 I can't see node 5, right? After that I can see node 6. So if I see from the top, I can only see node 2, node 1, node 3 and node 6, and I can't see the values 4 and 5 because 4 is covered by 1 and 5 is covered by 3. So I hope you have understood the overall asking of the question. Now how we gonna do this question? So to do this question, we are going to use 2 new concepts. The first concept name is, we are going to use a hash map. And I know that we haven't studied HashMap, and in the upcoming chapters we will talk about HashMap in detail. There is a separate chapter, separate session about HashMap or maps in general, right? And the second concept we are going to use is horizontal distance. So let us talk about HashMap. So to do this particular top view question, we are going to use these 2 terminologies, these 2 concepts to be particular. One is we are going to use the concept of hash map, and the second one is we are going to use the concept of horizontal distance of a tree, right? Now let us begin with our hash map. So a hash map is nothing but a data structure. You can say that we have studied arrays, we have studied array list, linked list. These are linear data structures, right? Now we are studying hierarchical data structure, which is binary trees. Similarly, hash map is also one of you can say data structures which stores data in the form of key and value. So in Java we have a concept of maps, and again these maps is divided into 3 different things: hash map, tree map and linked map. So these are the 3 different maps, and these maps are used to store data in the form of key value pair. And what I mean by key value is that, let's say that you are having one variable and this variable are associated with other values. Let's say that I am drawing some line, I am drawing some locus of a particular diagram of a 2D figure. Now in math we used to give like values, right? So x is equals to 3, y is equals to 2, after z is equals to 5, something like that. To store these values in a particular corresponding, because x is related to 3, y is related to 2, z is related to 3, it means that to store these relations we use HashMap in Java. Okay, and the best example I can think of right now is countries and its population. Let's say that I am having India, and India population here is 150, and I am having China population is something 200, and after that we are having US population is something 50, right? Now here I am in the key value I am storing countries, and on the value side I am storing the population of that particular country. And one more thing is that to store this, I have already told you that to store this data in the value of key and value, I use HashMap. Okay, after that you need to understand, you need to keep this in mind, even though this concept is new to you, and I will explain you in detail in the next upcoming sessions. But for now you need to keep this in your mind that key is unique in Java. In HashMap key is always unique, right? You can't create a duplicate value of key. It means that the best example is countries. India is only one, there can't be like many countries with the name India. India is only one country, India, and we can't have duplicates of India, right? Similarly, we can't create the duplicate values of key in our HashMap. We can't create duplicates of key, but we can create the duplicates of values. I hope it is not getting like out of your head, right? So we are going to solve this particular top view question using these two concepts. One is HashMap and the second one is horizontal distance. Now we need to understand, to use these two concepts I need to understand these two concepts, right? So first of all, we are understanding the concept of HashMap. So to store data in key value pairs, I create HashMap, and in HashMap the key is always unique. I can't create the duplicates of key, but I can create the duplicates of values. It means that let's say that there is another country, there is European Union, and European Union population is also 50. It can have the same value. US is also having the same value, and the European Union is also having the same value. But I can't create another US because it is a duplicate. My key is already existing in my HashMap, right? So I hope you have understood the concept of HashMap. Now let us talk about how we can create HashMap in our Java. In our programming, how we can create HashMap. So to create HashMap, what I will do is, first of all, I will import our packages. So I will import all the packages directly. So java.util.star, right? Now if you recall linked list, we used to write create linked list by just writing linked list, data type, and name of the linked list is equals to new linked list. Similarly, to create HashMap, what I will do is I will write HashMap, and after that I need to store the key value pair. So for key I need to declare the data type of key. So data type of key, comma, data type of value, after that my like angular bracket closing, after that my name, let's say that I am giving HM as my HashMap name, is equals to new HashMap, right? This is how I can create a HashMap in my Java. Now let us talk about the operation, how we can add, we can get, we can like delete elements in my HashMap. So to perform operations, to perform operations in my data, so for the given data, to perform operations, to add elements in my HashMap, for adding I will write map, or whatever the name I am creating, HM, the name is here HM, right? So I'm writing HM, my HashMap name dot put, and I will put my key, whatever the key I am putting, after its value I will write it here. So this is how I will perform add operation, and the time complexity of performing add operation is big of 1. After, to get an element from my HashMap, to get a particular element, particular value through my key, I will write HM dot get, and I will pass my key here. So by passing key, I will get my value as my output, and the time for this is also 1. And to remove a particular element, then what I will do is I will write hm dot remove and I will pass key here. So this will automatically delete this key value pair in my hash map. So the deletion operation is also big of 1. And one more thing is that hash map or maps are very efficient data structures. You need to keep remember this also, that maps are very efficient data structures because the maps use the concept of hashing. Hashing is another beautiful concept, one of the beautiful concepts in computer science. And by using hash functions, we make this data structures very efficient data structure, right? I hope you are getting it. And if you are coming from a background of cyber security or hacking background, then you have had the name hashing. So what big companies does is they store passwords. Let's say that we can take example of Google, we can take example of Microsoft, Apple, or our company as well. So what we do is that we don't directly store passwords. Let's say that a user is coming in and he is creating some password in my website, then we don't directly store this password directly in the form of text. Let's say that he is giving password as XYZ. Now I don't store directly this as in my database. I don't store directly XYZ. What I will do is using hash function, like there are many functions like salting and other functions. So using this concept, I will change this password into some string, n number of strings. I will store this as hashtag 123 hashtag something kind of in this form. So if my database got hacked, then and also he can't get the user password, he can't access the user's data because my password is storing in different form. This is known as hashing. Anyways, this is totally different concept. So I hope you have understood hash map. So hash map is nothing but to store data in key value pairs. I use hash map, and in hash map the key is always unique. I can't create duplicate keys. Now let us talk about horizontal distance. So there is a concept called as horizontal distance, which tells you that from a given route, what is the distance of my left part and what is the distance of a particular route of my right part. So what I will do is, in school we have studied number line, right? This is my number line and this is the 0th axis in the x-axis. This is the 0 value, 1 value, 2 value, 3 value, and this is my positive axis. And this is my negative axis, -1, -2, -3, and this is my negative axis. Similarly, the root node is considered as 0, right? And the left part of my root node are whatever the elements coming on my left part, those elements will become the negative elements, and the first element which is coming on the left part is considered as a unit distance, and the right element coming after, immediate after the root node, is considered as a +1 or +1 unit distance. So what I will do is that this is my root node and root node distance is 0, right? And the element which are coming on the left side are considered as negative distancing element, and the elements coming on the right side are considered as a positive distancing element, and the immediate element coming after the root node is considered as -1. So the distance of 2 is -1. After, the distance of 3 is 1 because it is coming on the right side and immediate element, and the distance of 4, it is beneath. So let's say that I am having element here, so the x-axis value is 0, right? So for 4 the x-axis value is 0, the distance value is 0 because it is aligning with my root node. Now here the 3 value is aligning with 5. 3 value is aligning with 5. So the value of 5, the distance of 5 from my root node is as same as my 3 value. So this value will become 5. The distance of root node and the 5 node will become 1. Now after here the distance here, the second node, right? So this value, the distance will become 6. So this is the concept of horizontal distancing and hash map. Now I hope you have understood the concept of hash map and the concept of horizontal distancing. Now you can ask, oh Jabir, you have explained all this thing, but how we gonna use this? how we gonna use this concept, these two concepts, to solve the concept of top view. So what I will do is, I will take an example. And this is my tree, right? So I will, first of all, what I will do is that I will create a HashMap, and the first key values is stored by horizontal distance. On the key value I will store horizontal distance, and on the values side of my HashMap I will store node values. And the second step is that I will do level order traversal for each and every node. So this is my level 1, level 2, level 3, level 4, level 5, right? So I will perform level order traversal, and as I iterate, I will add the node and the horizontal distance value into my HashMap. So I will perform level order traversal, and as I iterate, I will add the corresponding node horizontal distance value after its node data value into my HashMap. So let us dry run this thing. By dry running you will understand it. Now what I will do is, what I have done is, first of all I have created a HashMap. Let us say that this is my HashMap. My HashMap is divided into two things. The first one is my horizontal distance. In the key I am storing my horizontal distance, and on the other side, on the value side, I am storing the node value, right? Now I am performing level order traversal. So this is my level 1, level 2, level 3, level 4, level 5, right? Now here what I will do is that, what is the root node distance? The root node distance is 0, right? First of all I will store 0 here. After that I will store the node, so I will store 1 here. Now I will go to level 2. So after creating a HashMap, what I will do is, I will perform level order traversal, and as I perform level order traversal for that particular node, whatever the nodes present on that particular level, I will check for, I will add that their horizontal distance and node values in my HashMap. So here you can see that for the first level the horizontal distance is 0, so I will add their horizontal distance into my HashMap and along with their node value. So I have added the node and the horizontal distance. Now I will iterate through this level 2. Now in the level 2 we already know that the horizontal level for the left, the horizontal distance for the left side first element is -1. So for this particular element I will store -1 here. After that I will store 2 second node in my key value pair. Now after that, for this 3 node on the second level there are 2 nodes, 2 and 3. So for this 3 node the horizontal distance is 1. So I will store 1 here. After that, its corresponding node value. So what is the node here? 3. So I will store 3 here. Now after that I will come to level 3. So in level 3 how many nodes I am having? 1 node. And what is that node? That node is 0, and it is coming under first node. It is covered up by the first node. So what will be its x-axis distance? X-axis distance is 0, and I already have 0 key in my horizontal. This is my key, right? This is my key and this is my value. So in horizontal distance I already have 0 key, and I told you that we can't have elements or keys which have same values. So I can't have 0 again. So I can't add 4 into my HashMap. So I will skip that. If I can't add, if the key is already present in my HashMap, then I will skip that. And I will move to the next iteration. So on level 4, the fifth element horizontal index is 1 now. And 1 is already present. So I can't store 1 into my HashMap. Now I will move to level 5. So in level 5, the horizontal distance is 2. So I will store 2 as my key and its corresponding node, which is 6, into my HashMap. Now whatever the elements present in my HashMap, whatever the values of particular horizontal distance present in my HashMap, I will print that particular thing, and that output will be my output. That output will be my answer. Here the output is 1, 2, 3 and 6. Or I can sort this. I can sort this horizontal HashMap, and as I sort, I will take the minimum value. So my output will become 2. According to the key, I will sort the elements. So -1, 0, 1, 2, right? So 2 will come first, after that 1, after that 3, after that 6. So this will be my output, or if I don't wanna sort anything, then this is also fine. This will become my output. Now I hope you have understood the approach and the two concepts. If you don't understand these two concepts, go to the previous session and understand those concepts. Now after that, come to this approach, and this is the approach. Now if I write the code, then it will become super clear to you guys. So let us code that thing. So in the main program, what I will do is that first of all I will create a class info which stores the information of horizontal distance and the node details, because I am creating a key, right? And this key, this hash map, will store the horizontal distance and the node value. Because of that, I am creating a class, static class, and the name of the class is info. In this I will store two informations, which is node information, node. Now after that I will store the int horizontal distance. After that I will create a constructor public info, and in this I will pass two parameters, that is node. Let's say that I am passing a node. This is a constructor basically, so int horizontal distance. So this will initialize my variables in my class. So this dot node is equals to node. After that, this dot horizontal distance is equals to horizontal distance, right? So I have initialized my constructor, my variables through my constructor. Now what I will do is that I will create a function. Public static void type function, and in that let me give the function as top view as my function name, top view. In this I will pass my node, root node. So node root. In this, first of all I need to perform level order traversal. So for level order traversal, what I will do is in level order traversal I have like explained you that we use queue data structure in that. So I will create a queue of, let me give node, because I am performing operations on node, right? Instead of node I can give directly info of queue is equals to new linked list. Okay, now after that I will create a hash map of, let me give integer, because the horizontal distance is nothing but integer. After that my node value, because I am storing node, and the name is hm is equals to new hash map, new. Okay, this is showing some kind of error. Hash map is showing some kind of error. Okay, I need to give here capital M. So capital M. Okay, now I have created my hash map. Now what I will do is that I will print my elements. I will iterate. I will perform level order traversal, because before that I will calculate the minimum distance I got. Let's say that my minimum is initially my minimum is 0. After that I am creating two minimum variables to keep track, because I need to print the elements from the I need to print in this fashion, right? Here you can see that I need to print from the negative element, which is the minimum element, to the maximum element. I need to print 2, 1, 3, 6. So to print this in this order, I am using this minimum and maximum variables. So instead of sorting, I am using this minimum and maximum variable. So here maximum is equals to 0. Now after that what I will do is that I will run a loop. Before that I will add the initial elements. I will add the root elements. So I will add new info, and here I will pass root, and the maximum value root horizontal distance is 0, right? After that I will add q dot add null, because I need to specify the next line. I need to specify that this is the level 1 elements, after the level 2 elements, level 3 elements, like that I need to specify. That is why I am adding null. After that I will run a loop while q is not empty. In this I will create a current node of current. I will create a current of info data type is equals to q dot remove. I am removing the first element and I am storing that in the current node. Now after that, if current is equals to null, in this again I will check if q is empty. If q is empty, then what I will do is that I will break, I will come out of my loop. It means that there are no elements in my queue. So there are no elements to perform level wise traversal. That is why I will break. Else what I will do is that I will add q.add null value. It shows that I need to go to my next level. So this null will show that I need to go on the next level. Now after that what I will do is that I will write else statement. If my current is not null, then what I will do that I will check if my map dot contains that particular key. If my map hm dot contains key, and I will pass my key as a current dot horizontal distance. If this value is not present in my hash map, then I will add this value. So hm dot add, hm dot put current node curr.hd, comma my node, whatever the node I am getting, right? So I will pass this node here, current node curr.node. After storing, this is my if statement. Now I need to traverse, right? So if my current dot node dot left is not null, then what I will do that I will add that particular thing into my queue. So new info, and I will add curr dot node dot left, and I will store the maximum value curr dot hd minus 1. If curr dot node dot right is not null, then what I will do that I will add q dot add in this new info, and here curr dot node dot right, and here I will store curr dot hd plus 1. After that, my max value will become max is equals to math dot max of, and along with that, along storing with the current value, I will store the minimum value. I will change the minimum value. So minimum is equals to math dot max, math dot min of this minimum value, and my curr dot hd minus 1 dot hd minus 1. Which one is minimum? My minimum will become that. Now after that, here I can also add max is equals to math dot max of, here I can give maximum, comma curr dot hd dot horizontal distance plus 1. Now I can come out of my else statement, and after coming out of my else statement, I will run a loop for int I is equals to minimum, and I should be less than or equals to maximum, and I plus plus. In this, what I will do is I will print system.out.print. Here let me remove ln. I will print hm.get hashmap.get ith element dot data, and give some space here. So here let me explain what I did. First of all, what I have done is to perform level order traversal, I have created a queue of info data type, and I have created a class called as node, and in info class I am storing node and hd. So I have created a queue of info data type. After that, I have created a hash map which stores the key value as integer and stores the values as nodes. Now after that, I have created a min and max variable. So instead of sorting my hash map, I have created min and max values to keep a track, to print elements in a like correct order. I have created min and max. Now I have initially added the info root data, the initial root data and null value, because the level 1, after traversing my level 1, I need to show that I need to go on next level. For that, I have added null. Now what I did is I have run the loop until my queue become empty. Now after that, I am storing the current value, and if my current value is null, then I'm checking if my queue is null and current is null, then break the loop because there are no elements in my queue. Else what I will do that I will add null. This will show that I need to go on my next level. Now in the else statement I am checking if my key is not present, then I am adding that particular key into my current node, into my hash map. Now after that I am checking, I am performing the level order traversal for the left side and performing for the right side, and as I perform I am calculating the minimum and the max value here. After that finally I am coming out of my while loop and I am running the for statement, and in the for loop what I am doing is I am starting my loop from minimum to the maximum, and whatever the elements present in my hash map I am printing those elements. So this is the code for my top view element. Now if I run this element here, let me call the function here, let me call the function top view, and I will pass root here. I will pass root. So if for this tree, for this particular tree, if you see, first of all I will get 4, after that 2, after that 1, after that 3, after that 7, and 5 and 6 will get covered by the topmost element, by the root element, that is 1. Now let me save and run. So if I run this code, let me run, I will get the output. So you can see that we got the output as 4. This is the tree, right? For this tree, you can see that first of all I will get 4, 2, 1, 3, 7. I hope you got the logic, and this is the code for calculating the top view of my overall given tree. So I hope you have understood and learned something, and the lecture is again 1.5 hour, 1 hour 20 minutes again. So now we will end this part, and in the next part of binary trees we will talk about some more concepts and some more problems. After that we will talk about in the next sessions we will talk about hash map, hashing, heaps. There are many chapters to come. So with that being said, I will see you in the next one.